Right now, the top of this skyscraper is swaying, exactly as its engineers intended. Because if you stopped it from moving completely, the forces inside the structure could become even more dangerous. This tower is 24 times taller than it is wide, and once a building gets this slender, the real enemy isn't gravity. It's something you can't even see: wind. Above 40 stories, wind forces can make an entire building sway and twist, sometimes enough for people inside to actually feel it, even when the structure itself is completely safe. So, how do engineers control something they can't even see? They spend months testing scale models inside massive wind tunnels to understand exactly how each building reacts. Some towers even hide giant tuned mass dampers, 800-ton weights that move in the opposite direction of the building, reducing sway and keeping occupants comfortable. But wind is only half the battle. The other half is underground. Manhattan is famous for its bedrock, but it doesn't sit at the same depth everywhere. Move just a few blocks, and the entire foundation strategy changes. That's why engineers carry out detailed geological investigations before a single pile is driven. Then comes the part most people never see. Today's skyscrapers are built digitally before they're built physically. Using LiDAR scanning and building information modeling, BIM, engineers create a precise digital twin that detects thousands of clashes between beams, pipes, ducts, and cables before construction even begins. And there's another challenge shaping every new tower: New York's Local Law 97. Exceed your building's carbon limit, and the city charges $268 for every excess metric ton of emissions, every single year. Today, building taller isn't enough. Skyscrapers have to be smarter, more energy efficient, and built for the future. So the next time you look at the New York skyline, remember, you aren't just looking at architecture. You're looking at thousands of engineering decisions working together to make the impossible possible.